Hi everyone, today we're going to review geometric sequences. If you remember back to chapter 4, we learned about arithmetic sequences already this year. An arithmetic sequence was a sequence where you obtain the next number by adding the same number every time. That number was called the common difference. A geometric sequence is similar in the sense that there is the same number you're using each time to get the next number in the sequence. However, instead of using addition, we are going to be using multiplication. So geometric sequences are obtained by multiplying. The number you multiply by each time to get the new number is known as the common ratio. Geometric sequences have a formula just like arithmetic sequences did. We'll get to that in a little bit. I just want to do two quick examples of just what geometric sequences are. Our first example has the numbers 2, -6, 18, -54, and 162. They're saying that it's a geometric sequence, and we want to figure out what the common ratio is, and then the next two terms. Again, the common ratio is just the number that you are multiplying by to get from one term to the next. So to get from 2 to -6, we're multiplying by -3. To get from -6 to +18, you're also multiplying by -3. Positive 18 times -3 is in fact -54, and -54 times -3 is positive 162. So that means that our common ratio in this case is -3. And then to find the next two terms, you're just going to continue the pattern. So 162 times -3 is -486, and then -486 times -3 is 1,458. When you have a geometric sequence and the numbers are alternating between positive and negative, that means that your common ratio has to be negative. It's the only way to obtain that pattern of positive, negative, positive, negative. Example 2, the numbers that they give us are 500, 250, 125, 62.5, 31.25, etc. In order to figure out the common difference, we're going to try to figure out again what you're multiplying by to get 500 to turn into 250, 250 to turn into 125, 125 to turn into 62.5, and 31.25, obtaining that from 62.5. The way that you would do that is basically take half. So the common difference in this case would be 0.5 or 1/2. Either one is acceptable. Your instincts might be to say that you're dividing by 2 each time, but just like with arithmetic sequences, we never said subtracting by 4 each time. We just said adding -4, the additive inverse. Here you're going to refer to the multiplicative inverse. So instead of saying divide by 2, you're multiplying by 1/2. If we continue the pattern, 31.25 times 1/2 is 15.625, and 15.625 times 1/2 is 7.8125. Now let's talk about the formula. The formula is A of n is equal to A of 1 times r to the n minus 1 power. A of n just refers to the nth term. It was the same thing for arithmetic sequences. So if you're finding the 15th term, it would just be a little 15. A of 1 is the first term in the sequence, whatever the first number is. R is the common ratio. And then this n here is the same as this n here. So if we're finding the 15th term, we have A of 15, then it would be r to the 15 minus 1. Please remember your order of operations. You're going to always do your exponent first, your powers first, before you do the multiplication. So before you multiply the first term by r, you have to raise r to the n minus 1 power. Okay, let's look at a couple more examples. What is the 13th term of the geometric sequence 8, -16, 32, -64, etc.? Again, like I previously mentioned, if the numbers are alternating between positive and negative, then that means that your common ratio is going to be negative. To get 8 to be -16, you're multiplying by -2. And you do want to just make sure that that still works for all the other numbers. -16 times -2 is positive 32. Positive 32 times -2 is -64. So it does work. The things that we need for this formula, first of all, we're looking for the 13th term, so that's why this number here is 13. And then we need to know the first term, A of 1, times R, which is the common ratio, which we just said is -2, to the 13 minus 1 power. Again, if we're looking for the 13th term, we're actually raising r to the 12th power. So our first term is 8, and our common ratio is -2. When we plug those numbers into the formula, it looks like this: 8 times, in parentheses, -2 to the 12th power. Always put parentheses around your ratio, because when it's negative, if you don't use the parentheses, you could lose the negative sign. If you didn't have a calculator, you're going to have to do -2 to the 12th power first and then multiply that by 8. You are absolutely allowed to use calculators for this. Graphing calculators are preferred, but whatever you have at home or on your computer is perfect. When we actually evaluate this, the answer is 32,768. Okay, let's do one more example. The first term of a geometric sequence is 128, and the common ratio is 0.5. What is the 10th term of the sequence? So this problem is a little nicer because they told us that the first term is 128 and the common ratio is 0.5. So you don't even have to investigate the pattern and figure those numbers out yourself. They're already given to you. And then if we're going to find a of 10, or the 10th term, then I'm going to plug in 128 times 0.5 raised to the 10 minus 1 power, because once again, if we're looking for the 10th term, then we're raising the common difference to the 10 minus 1 power. I'm sorry, I keep saying common difference, common ratio to the 10 minus 1 power. When we evaluate this, it's 0.5, that's not a negative sign, that's a decimal point, 0.5 to the 9th power, and then times 128, which is actually 0.25. Okay, you're going to complete some geometric sequence problems on a Google form now. If you have any questions, please just comment to let me know. Thanks.